Okay, one more side. Basically, this problem would have been for you. You just set them equal to each other, right? And solve, and then whatever m is, we'll make this a parallelogram. Okay? So this is 3m plus 8. Subtract 3m from both sides. Well, whatever. The answer is m is equal to 6. Okay? I'm not worried about that. So that makes these congruent and parallel. So by rule number 5, it's a parallelogram. Okay, this is what I want to talk about, this coordinate geometry. Okay, so we're trying to prove that this is a parallelogram. And usually parallelograms, you would prove that the opposite sides are parallel. Okay, so slope. Okay, we want to know the slope of this one and this one. Okay, those opposite sides should have the same slope for it to be parallel, right? So this is up 3 and over 2. Remember, you start from the left side and go up and over. Okay, so that's 3, 2, so the slope is 3 over 2. Okay, now does this have the same slope? Don't let it bother you to go inside. It's okay. So go up 3 and over 2. You start from the left, go up or down, right? Remember? Okay, even kind of looks cool because of it looks like a 3D shape. I know I said that before. Okay, so that's 3 and 2. So this is 3 over 2. So these two sides are parallel, right? Because they had the same slope, right? Okay. The green sides should be parallel as well if it's going to be a parallelogram. So this one, you start from the left like always, and you don't go up and over, you'd have to go down and over. Now if you go down, it's negative, right? So you go down 1, and then what is that? 1, 2, 3, 4 to the right, okay? So that would be negative 1/4. For the slope, right? And then this one should be a negative 1/4 as well. Remember, you start from the left, go down and over. Okay, down 1, which is a negative 1. You can't see that, but just know it's there. That's a negative 1, and that's 4 this way. So negative 1/4, okay, is the slope of this one. Okay. All right. So these are parallel, and if both pairs of opposite sides are parallel, then ABCD is a parallelogram. Yay! Okay. And while I'm at it, let's talk about length or distance. What is the length of the two pink sides? Okay, AB, how long is it? What is the distance? Right? These were slope, right? This is distance. Okay, remember we used the adding Pythagorean theorem, and if we want to, we can just, let me just do this here, make a bunch of right triangles all the way around. Okay, so this right triangle is a 3, 2. This one's a 1, 4. It's not a negative 1, 4. Distance is 1, right? You go just, that's a 1, 4. This one is a 3 and a 2, right? And then this is a 1 and a 4. Okay, let me put those numbers on there. That's a 1 and that's a 4, just like that's a 1. Just a 1 because it's not slope. We're just talking about how far it is. Okay, so that's 1, 4. And then this one's a 2 and a 3. So you've got AB, which is this one, right, is a square root of 2 squared plus 3 squared, right? Remember? Okay, so that's something. 9 squared of 13 is, I don't know, 3 something. Okay, and then the other one should be the same thing, which is, what are those letters? A D and a C. So that's DC. And that one's a 2 squared plus 3 squared, right? Because it uses a 2, 3 right triangle. This one's a 2, 3 right triangle. And then the other two, AD, it's hardest thing is to find the letters. AD and then BC, right? So those two should have the same distance as well. Okay, so those are 4, 1, 4, 1. Okay, so that's 4 squared plus 1 squared, and 4 squared plus 1 squared. I don't have a calculator, but I know that's a little bit more than 4. Okay, so this is a little bit less than 4. So these two are the same length, and these two are the same length. Okay, so the opposite sides are congruent as well, which it should be. Anyway, I just wanted to show you this in comparison. All right, very good. Have a good day.